Okay, let's discuss the respiratory lab. So the lab is actually for three things, okay? So the first part of the lab, this is the respiratory lab. It's actually for the typical chemoreceptor reflex, right? We've done this before for lecture, where you're asked to indicate the components of the loop, which is the stimulus. So we got stimulus here, sensor, integrator, effector, response, and the result. Okay, so let's say the stimulus here will be maybe an increase, it has to be an increase in CO2, that's stimulus, or a drop in pH. That's stimulus, and then what goes from there? So we can fill this in. You know, the sensor will be chemoreceptors, integrator, I'll leave it for you, integrator, the effectors, muscles of breathing, and the response, and then the result will be that the CO2 level will drop. This is the result you're looking for, okay? So make sure you can fill in the remaining three things for that one. Then we ask you to breathe and determine how long you can hold your breath for, okay? So you have three conditions of breath holding. One of them is normal breathing, then hold breath. Okay, so that's condition one. The second condition is you will breathe in CO2 and then hold your breath. So when you blow into the bag, you're breathing in CO2 back into your lungs, hold your breath. And the third one will be for you to hyperventilate and hold your breath. Now, keep in mind that your breathing is triggered by CO2. And when CO2 is high, you're forced to breathe. So here, normally, you want to see how long you can hold your breath for before levels of CO2 get too much and you have to breathe. Here, we're asking that if you were to increase your initial amount of CO2 in your lungs or in your blood, would you hold your breath longer or shorter? So let's say that this is, say, maybe 20 seconds here, all right? This one should be less because here you're already beginning with a high amount of CO2 already in the blood. And this one should be longer because here, when you hyperventilate, you drop your levels of CO2. Here, you increase levels of CO2. So these two factors alone will drive your breath holding to be either longer or lesser than normal. So get that straight as well, please. Then we'll do a spirometry assessment, way of measuring your various lung volumes here. So for the spirometry, remember, so in the spirometer, you're going to have this spirometer is upside down, by the way. This spirogram is upside down. Usually it's flipped around. So we go, this will be a TV, right? Let's make this maybe made of 4 liters. So TV will be so this will be maybe 4.5 liters because TV is typically 500. So then you have TV, and then you have your ERV, normally goes down this way. So the way it is on yours, your IRV goes down this way, comes up, okay, and this will be your ERV, all right, and then back to your TVs. So from here to here, from here to here, that's your IRV. How much you can bring in beyond normal intake? From here to here, that will be your ERV, okay? That's how much you can push out after a normal out. Then the combination of ERV plus your IRV, that will give you your VC. Okay. And then let's say that this is 0, it's going to flip around again. This should be reversed. Let's say down here is 0 liters up here is say 7 liters. Then from here, say from the maximum here to here, that will be your residual volume. How much you have left in your lungs after you exhale, RV. So then from RV down to your IRV, that's your TLC. Okay. So label for me the different parts on the spirogram, and then get the values down as well. You know, your T, it has a TRV, TV, ERV, VC, what's predicted, what your deviation is, and tells you how to get the deviation. Make sure you get it as well. IRV there, RV here, and RV is your actually calculated RV. And if you have to calculate the RV, then do so. Then you can find the TLC. So this RV, don't do it this way. Okay. It's why, but you must first use the math here to calculate it, and then using that, you can get TLC. Because TLC will just be your VC, that's TLC, VC plus the RV. You get your TLC on your paper there. All right. Then we'll do another one where we will look at your force VC. How much breath can you push out, you know, maximally? All right, so we have this kind of graph here where we do this like this, up like so. So this is volume, you can push out, and here's time. Okay. So on your graph, it doesn't label them, but the grids are 1 second. So you have these grids on your graph like that. Okay. So here, this one will be 1 second, 2 seconds, 3 seconds. So right here would be your FEV1. This would be your FEV2. Here would be your FEV3, and here this maximal value is your FVC. Okay. So we actually find me those values and put them in here, and then do your percentage of FVC. Percentage is just your, for example, your FEV1% is equal to FEV1 over FVC times 100. Okay, we want you to get that one for the percentages over here in the second column. Okay, and then they should match a certain predicted value, and if they don't, then that may indicate obstructive or restrictive diseases of the lungs. Okay, that's it. So there will be a quiz on this part. So make sure you know how to interpret a spirogram, okay, how to calculate your FEV1 and FEV2s, their percentages, and how they can be used to predict obstructive or restrictive diseases of the lungs.